Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. Polar protic, pp high dielectric constant dipole moment and has OH or NH bonds capable of hydrogen bond donation. Polar aprotic, a high dielectric constant dipole moment but no OH or NH bonds, cannot donate H bonds. Nonpolar aprotic, NPA low dielectric constant, no OH or NH bonds. Nonpolar protic, NPP low dielectric constant, but has OH or NH bonds, rare category. Moving on to the next step. DMSO has a highly polar S is equal to O bond giving it a large dipole moment, dielectric constant ~47. It has no OH or NH bonds, the oxygen is only bonded to sulfur, and the two methyl groups have only CH bonds. Therefore, DMSO cannot donate hydrogen bonds. Classification, polar aprotic, Pa. Moving on to the next step. This molecule has a polar S is equal to O group making it polar overall, and it has an NH2 group which contains NH bonds capable of donating hydrogen bonds. Therefore, it is both polar and protic. Classification, polar protic, pp. And for the final step. Toluene consists of a benzene ring with a methyl substituent. The molecule is essentially nonpolar, dielectric constant ~2.4 due to the symmetric electron distribution of the aromatic ring and the nonpolar methyl group. It has only CH bonds, so it cannot donate hydrogen bonds, aprotic. Classification, nonpolar aprotic, NPA. DMF has a highly polar amide C is equal to O group giving a large dipole moment, dielectric constant ~37. The nitrogen bears two methyl groups, so there are no NH bonds available for hydrogen bond donation. The carbonyl oxygen cannot donate H bonds either. Therefore, DMF is polar but cannot donate H bonds. Classification, polar aprotic, Pa. A cannot be PP because it lacks any OH or NH bonds. B cannot be Pa because the NH2 group provides protic character. C cannot be Pa or PP because its dielectric constant is too low to be considered polar. D cannot be PT because both NH bonds are replaced by N-methyl groups, eliminating H bond donor ability. Therefore, the correct answer is A, Pa, B, PP, C, NPA, D, Pa. Therefore, the correct matching is A matches Pa, B matches PP, C matches NPA, D matches Pa.